All right, getting back online after somewhat of an abortive attempt at doing this just a bit earlier today. I had some problems with my streaming machine where it seemed like the easiest solution was to just restart to open broadcast server, which itself wouldn't have taken long. But the other thing that happened was I actually forget who, actually maybe I can find out. Somebody was helpful and notified me that, oh, I think I might have already lost that chat screen. Sorry, somebody was helpful enough to point out that my old WordPress blog, where I still post my new videos, was helpfully hacked by someone. And so I went and investigated what happened. And as far as I can tell, they never actually created an account or anything. They definitely didn't. I mean, the machine it's on is like a shared host that's pretty locked down and isn't mine. But it looks like what they did was they exploited a bug in WordPress to write to the database and then just wrote some stuff to the blog in order to test if it would show up in any search engines later. So I just had, I just had to restore that post from backup and make sure they didn't mess up anything else. And then I updated everything and backed it all up again. So the site is back, and I'm back, and the cat's back, and we're ready to get back to some VFD work. So Tuco's pretty chill over there. I don't think we're going to be needing to play fetch with him super immediately. Let's see. So getting back to it, for a little context, in case you're tuning in here in the archive, since I guess it's good to give more context than less. Pardon me. I worry that I repeat myself, but given how much stuff there is in the archives, you know, I'm sure not a lot of people are going to just like watch stuff completely through. You know, I suspect a lot of people just seek around and try to find interesting stuff, and in that case, it's probably helpful to have bits of context a little more often. So anyway, on this stream, this is a continuation from kind of well, broadly speaking, this is a very, very small project that I expect should only take a couple more streams to actually finish, since it's basically an object that happens to be useful for my streams, but also kind of breaks up the monotony of just working on these giant projects one little piece at a time. So it seemed nice to have the occasional smaller project that can be completed pretty quickly. So in this case, I did a previous stream where I pulled this old vacuum fluorescent display out of an old project of mine and kind of did a kind of a retrospective or post-mortem on that old project. Which was kind of interesting because it used some really early USB technology, and so it was kind of interesting to go back and look at that in comparison with what's available now. Let's see, can I do this without having to look at all the buttons? There's that wheel. No, still trying to find the wheel. Is it this one? Yeah. Yeah, if I stop that too much, it flickers. I guess I'll have to turn the aperture down. Starting to remember how these controls work. It's been a while since I've had to do a lot of manual photography on this channel. I kind of got the lighting set up pretty consistently, but, you know, whoa, stuff like LCDs and VFDs. So that looks a little more like what I'm seeing in person, maybe more like that. Hey Tuco, what are you doing? You had your nap, I guess. So, I think while we have this set up, it might be nice just to do those oscilloscope tests I mentioned. So, you know, I want to do some tests on the brightness on this and to see what kind of case design might work, because the CAD is what I really want to focus on today, but I thought it might be nice while we had this set up to just poke around with the O-scope and see what these drive signals look like, both for the segments themselves and for the heater filament. Hey Tuco. I guess I should bring the camera back over. Oh, hey buddy. think this tripod is just starting to grow all of the components of a camcorder distributed around the tripod. Because it's like a standalone camera that just outputs SDI and a standalone monitor that takes in HDMI and then some converter dongles. It runs off of 12 volts. Hey Chico, you're just going to orbit the camera again. Isn't that meta? You just want attention? Being a cat and all? Being an emotionally needy little tiger? You're just rubbing your face on me now. This cat is just unfathomably cute. Anyway, so yeah, let's get some scope probes out. Whoa, Chico, don't touch my scope probes like that. I think we'll only need 2 for this. That's the one we want. All right. This is the scope and hardware view, which I've been missing. All that scope and software view we've been using lately. Let's also put this under here, because, you know. Usually that sits nicely, although these connectors are a little long, and so it's squeaking really badly if I actually slide it along the glass. And, hey Tuco, I hear you, boy. A little nervous about this serial thing just hanging there, so I'm going to stabilize this a little bit with yet another vise. Try not to short it out to the vise itself. Oh, there's something sticky on this table. I think I have some intentional sticky bits on this glass to hold parts down. That's what I wanted. Oh, Tuco, you're not in frame. Tuco, you're not a very good self-videographer. I guess he needs some AI assistance for that to really work, you know? He just wants to be near the tripod, so I always have to aim this thing really far down. Oh, you've got a bolt now. Just when I thought he was going to be napping, now he wants to play again. Well, hopefully this won't break my video capture setup again. Hey, Teak, where's your bolt? Weird little cat. All right, let's have some channels. So, I'm gonna put on the little grounding clips actually, because we don't need the super high frequency stuff going on. And I want a more convenient ground. Where is a convenient ground? I think I might need to add one. Oh no, I think I can grab that. There's a pin that I remember is ground on that connector, and I think I can grab that with an alligator. Or possibly a female header, and then stick 2 alligators onto that. That might be a little more secure. Let's do that. This is not going to give me an electrically awesome ground, but it's going to be less likely to short out than some of the other alternatives. And I don't think these signals are going to be high frequency. At least not where we're going to need to worry that much about the scope wiring. And I've still got one of my lights turned off here, so I mean, that kind of makes sense, I guess, for working on the VFD on the desk, but when we set it up on the pole, I'll want to see how it looks with both lights on. So, I think I want that thing and this thing. I like all the little parts that you can add and remove on scope probes. It's very fun. It's kind of like a Lego kit. I guess there's a part of me that really just enjoys having kits of things that you can attach together, whether they're, you know, literal or software. I like making things with construction kits, but then I also really appreciate making construction kits. So then it's nice when someone else does it and I can use it. I get to appreciate it too. You can have room for 2 alligators. Barely. Alright. Hey, buddy. So I'm just going to... Oh, that's not a good connection. Might have to do something more deliberate with this. Hey, buddy. Is this what you want? Weird little tiger. Let's see. How am I going to solve this particular kind of grounding problem? Hey, Tuco. I mean, I don't want to make this really that much more worse than it absolutely has to, so I might just cut this wire and strip it long enough that I can attach the alligators multiply. Don't really want to introduce like a breadboard into this situation necessarily. Oh, this should be, oh man, this is thin wire. Is this even copper? I don't know if that's copper. Man, these are the worst wires. Man, suckers will buy anything on eBay. Alright, well, let's see what we can do with that. At least these alligator clips are really nice. Hey, Chico. Yeah, there's another discussion in the chat, as happens every so often, about real-time tracking for Tuco, for a Tuco camera. And I think that's on the list. Part of what I was doing recently with this, you can kind of see this contraption that I've got going on the tripod behind me. But part of that was, well, it works a little better than the webcam I had been using. But part of why I did it that particular way was I wanted to try all these components with each other to see what would work for like a camera that I could introduce into some kind of robotic apparatus. So I think that's pretty much what we want. Like that camera is really small and has pretty good picture quality, and I can, you know, as long as I kind of choose whether I'm doing like close-up or wide angle ahead of time, and because that also changes the focus a lot, then I can pretty much live with manual focus and manual zoom, and then just have the camera physically move around on the robot. So this might be a pretty good platform for that. Hey, buddy. And then actually, I wonder how much of the tracking you could do with assistance from the camera itself, since, you know, Tuco's got a pretty unique appearance. He's got the stripes and all that. And these cameras also have pretty good low light vision, so it might even be able to track him when it's pretty dark in here. And it doesn't even always get that dark, because there's you know, there's lights coming in from the neighboring warehouses next door and stuff, so there's a little bit of light here even at night. Hey, Chico. Oh, there's another good question from chat about the power usage of the display. I actually have a meter right here, so you can see in real time. It tends to vary between about 0.4 and 0.6 amps, depending on how much is on the screen and how bright it is. Let's try to put that in front, maybe. Yeah. So you can kind of see right now it's actually only oh, is that right? 0.1 amps? Wow, that's lower than I would expect. I mean, it's not drawing much, and maybe it doesn't take much power to keep it warm. I don't know. Let's see what... Well, I don't want to unplug this until I have the terminal open on the machine that's running this program. Right now I just want to throw it on the scope. But that's... Yeah, that's suspiciously low. Usually I would expect this to draw a little more, actually. Huh. Hey, Tico. Alright, let's get these scopes hooked on. So, you can actually see the filament connection. Let's see if I can get that on the cam. I need to tape this down. Okay, otherwise that's going to risk disturbing the delicate wiring over there. So, yeah, you can kind of see the fine wires here. Oh, I should be recording this. I wasn't recording any of that. That's dumb. Let me get a wide angle shot before I mess that up. See, this is not going to help with that, because it's only going to be able to monitor the stuff that's recording onto the network, not the stuff that is, well, that I should be able to see on the screen. Anyway. So, yeah, it's a little hard to see, but you might be able to see these fine horizontal wires. And the wires kind of end right over here on this bar that has several little metal springs. And you can actually see the lead frame actually extends to short all three of these pins together. And I think it does the same thing on the other side. Yeah, I think it's all 6 of those pins for one side of the filament, just to, you know, really reduce the resistance of that connection. And then I think we've got basically the same arrangement on the other side. I think that's still 3 pins. Let's turn on a little more light so we can see the structure. Oh, Chico, you're like right next to my foot down here. It's a cute place for a cat. That is quite some glare. Whoa. Oh, that's pretty. Doesn't show the wires that much, but it shows the grid nicely. Hey, Tuco, I hear you. I'm just in the middle of a thing. Oh, let's get my hand out of that by maybe propping this up. Oh man, this is almost a shot that I would bring out the disco ball motor for. Hey Tuco, I hear you, really, I do. I get way too into photographing this stuff sometimes. But man, that's half the fun with VFDs. Let's maybe slide. Hey Tuco. this wire is just ugly relative to the VFD. Let's get that out of the frame for a sec. Maybe tape that down too. Wow, man, this new tape dispenser is sharp. That's pretty great. I just gotta learn how to hold it so that it doesn't bite me. I hear you, little dude. Who's my favorite tiger? Huh. Oh, I hear you, Took. Oh, Tuco. Okay, let's get a little more glamour shot of this and then throw it on the O-scope. Man, this is the fun part. You get to like fuss the light until it looks just the way you want it to. I am going to get around to showing off the wires, I swear. You can kind of see them better on the right side, actually, in this light. You'd probably be able to see them all right on the final HD footage from this camera. The viewfinder is a little lower res than the actual recording. That's maybe better. That needs some adjustment. I'm just like shimming this with whatever random stuff is on my desk. In this case, it's a spudger. Oh. Man, there's some kind of visual ASMR about this. It's like you kind of get the feeling that you're getting close, and then all of a sudden, there's something tingly in your head when you just hit the right light angle. At least that's how I feel about it sometimes. There is a cat hair on the top, though. I hope I remember which is post-cat hair cleaning during editing. I'm sure it'll be much more apparent when I'm actually editing the full res footage. Hey, Tuco. I hear you, little dude. Alright, well, let's put this in a somewhat more stable position and just get some scope probes on it. Because I want some voltages, I want some waveforms, I want some alternating signals. You know, the usual. All the stuff we came for. Oh, that's kind of pretty too. Can I get this light? I shouldn't mess with this light too much, it's on the microphone. Ooh, that's kind of pretty. Maybe I'll just turn this light back off while we do measurements. Or at least turn it down. Well, I can't turn it down enough given that we're pointing directly at the lights. Let me just put this back where it usually hangs out. Alright. Oh, that looks nice. Oh, I wonder if we can get this dark enough to see the wires glowing, because they are actually glowing faintly red. And it would be really cool to get that on video. I will need to turn this light off and probably crank up the ISO. Getting used to where the ISO button is on this. I don't know how I got the ISO and the exposure backwards. It was like, what kind of crazy low ISO is 30 anyway? But I don't know, this UI is super weird in video mode still. I keep pushing that and then looking for the wheel that I'm supposed to turn because it's just so tactily unintuitive, at least with the camera at this angle. And, oh, there's the wheel I'm supposed to be turning. No? I think I just started and stopped the recording because I pushed the... So this, okay, that's ISO. That's great. Well, I think it needs less ambient light for sure. Let me put like a shroud around this. This is not the quietest solution, nor the least conductive, but it's pretty opaque. Oh, we're still getting a bunch of light, but let's see if I can block more of it coming from in the window. Oh, are we getting some red? I might have to turn the brightness of the display pattern down too. Hello, I'm back here still. Hi. Okay, I guess I have to do the thing where I SSH in and change the brightness. Oh man, where is my mouse? Hey Tuco, welcome to the keyboard. Oh, I need you to be slightly less in the way, Tuc. How do I even? Is it? I think I want this one. Hi. Yes. Was I smart enough to run this in screen? Yes. I guess I didn't have that. Why do I not have that on? If I had the other view on, you would have been able to see the VFD stop animating. But I still had that turned off for some reason. Anyway, it was basically that, and then less of that. I think I can get more of this light out, actually. Let me take these scope probes out. And oh, that's looking good. This feels like this time. There's a photo of me from like this job I had in college. I was like hiding inside of a cardboard tube, and it kind of looks like that. Who's that? I'll get a clamp to hold this together, or a paper clip. I've got these lightweight clamps, which will work. Whoa, that's kind of cool. That particular light leak? Huh. That was unintentional, but it's kind of nice. Alright, what can I do to improve this situation? Ooh, that's kind of getting better. Welcome to the real-time photography experiments of scanlime. Yeah. Okay, and now let's see if I can turn up the ISO on the camera. Well... Wow, that's really subtle. It's looking interesting though. How far up does the ISO even go in this mode? Oops. That was the limit actually. I can open that up a little more. And man, that's interesting. Let's see if we can get different effects with the... This might just be something I have to try again at night. Honestly, doing this in the daytime is probably not the best idea. But it sure looks interesting. I'm probably going to get some interesting footage out of this. Oh, yeah. I mean, I could close this up a lot better, actually, than what I'm doing right now. The flicker reflected on that foil is kind of interesting, too. I think I just need one more clamp. I wonder if any of this audio will be interesting. Alright, maybe I just need a place to anchor this down. Cool. Let's lock that somehow. Great. That's closer to what I wanted. Now let's play with the brightness here. So if I were to just run this at the same brightness we had, it would probably be kind of like glowy and interesting, but whoa. You might be able to see a little bit of the red kind of after image of the wires after the green goes past. I think I had an easy way of changing the brightness in software. Yeah, makes it a little harder to see the individual levels. I think that just uses whatever the brightness was set to previously. Anyway, I think this is maybe the easiest way to specify a brightness. So that's the minimum. That looks pretty cyberpunk. Yeah, it's still not really even dark enough to see the wires, but Might try again when it's actually dark. Still probably got some interesting shots. What else should this say? I mean, I guess clearly I could try doing that. That looks kind of neat. Slightly too long. Anyway. Oh, Grikana from chat just tweeted a pic of her VFD filaments glowing, so maybe we can at least demonstrate that on the stream. Let's see if I can find that. There we go. Yeah, it's really subtle, but there it is, those horizontal wires. Her VFD is really big compared to mine, I think, so these wires are a lot more numerous. Cool. Alright, so what does this look like at max brightness? Whoa. You can definitely see the VFD light reflecting off of the wires, though, even though you can't really see the wires glowing. Whoa. So yeah. Anyway, that's fun. Let's maybe take this down and go back to the oscilloscope view. Gotta actually put that foil away, or Tuco will make a huge mess of it. It's one of those things I do have to take away from him. Oh, the camera is so saturated. Let's fix that perhaps. We don't need the ISO 6400 right now. I'm still so not used to the way that wheel is on this camera. Oh, that's pretty. All right, let's oh, what does auto ISO look like these days? Too much. That seems like an okay compromise if we actually want to see the circuit right now. All right, let's put the graph thing back on, because I think that was more interesting than just some text. Cool. Alrighty, so scope time. Oh, Tuco's sitting right behind the oscilloscope. I still have this problem where a lot of my layouts have Tuco Cam cropped in slightly unintuitive ways. And so if I'm aiming the camera using the monitor over there, which is always 16:9, then I have all these weird crops that are going to be different. So that's kind of a neat angle. Hey, Tuco. All right, cool. So let's get these back grounded and take a look at the filament voltage. So the power supply for a VFD is pretty interesting. You can actually find a lot of specialized circuitry that ended up evolving to be like an integrated like an integrated VFD power supply, since you need a combination of a high current, low voltage AC power supply for the filament, and a higher voltage DC power supply for the actual phosphors. And generally, the way these are built, you want that low voltage supply kind of riding on that high voltage DC supply. So I suspect that's what we're going to see here, but it'll be interesting to check my assumptions with the actual scope. So definitely, preparing to see some voltage. I expect, just from memory, I think these are probably going to be between like 60 and 80 volts or something like that, but we'll find out. But we should expect them to be somewhat high voltage at this point. So ground is attached. Let's just stick the yellow channel on the left electrode here. So we determine that these groups of pins are all ganged together for, these are all supplying current for the filaments on the left side and then correspondingly on the right side. So that's pretty big there. Cool, so let's figure out what's actually going on there. Is this DC? Huh. So that's interesting. I wasn't expecting to see that turning on and off, but maybe that's actually part of the brightness modulation that we're seeing. Let's see if we can trigger on that. Oh, and it's changing frequency quite a bit. That does appear to be pulse width modulation. That might be changing because of the display changing. I wonder if that's related to the power supply or to the display pattern. Anyway, the voltage there actually isn't that high. It's like 15 volts. So let's see what the other side looks like. Let's get these traces pretty much synchronized. Oh, I don't want bandwidth limit. Okay, so those are the same settings now. And I'll just stick this on the other side of the filament. Wow, that's interesting. Well, I don't know which of that is, this might all be power supply, or some of this might be related to, display brightness modulation. So let me just try simplifying this. So let's try just displaying something at full brightness. Okay, what did that change? That did seem to change the frequency of this. Might just be related to the power supply using different, being under a different load, though. So the voltage actually seen by the filament is going to be the difference between these two. So we should expect that to be a relatively low voltage because the filament doesn't have that much resistance. And we would also expect it to be an AC waveform. And just from looking at this, we can see that it is AC. So it's using the filament as, one of the electrodes in the, that's where the electrons kind of accelerate off from. So that has to be one of the terminals that we develop the relatively high voltage across. But in addition to that, the potential across the filament has to keep. So I don't know. I don't actually know whether it's the I mean, I guess as far as I know, so I clearly need to do some more research to fully understand this, but what I've heard is that the voltage across the filament itself needs to be AC. And the other possibility that I can imagine being important is the voltage between the filament and the the actual phosphor. So I think that's actually got to be DC for this to work. I think I forget which one's the anode and which one's the cathode, but we can measure that pretty easily. And then the filament actually acts as the other electrode, and then to prevent whatever this detrimental effect is that I clearly don't understand very well, the filament needs to be exposed to AC. And I think that has to do with like an electroplating action occurring on the coating of the wire, but I don't really know the details, so I shouldn't just make stuff up there. This is interesting. Let's try just adding a math waveform so we can just see what the voltage between these two probes is. And it won't be perfect because the probes aren't perfectly matched, but it'll be enough. We'll be able to see what the filament is seeing for the most part. So let's put these up here. Interesting. Is that right? So where's our baseline here? So, okay, so that's with the ground. Oh, this is so weird. Okay, that seems right. So we've got these long, kind of noisy regions where the yellow trace is a little bit above blue, and so that's where the math trace shows a small positive voltage. And then we have these large negative voltages. So it's not a particularly balanced waveform. It's not a very good AC power supply, but that's interesting. What frequency are we looking at? This is 5 microseconds per division. Let's measure 60 kilohertz. So let's also see what the RMS voltage across the coil is. So it's putting like 7 volts across that filament, 7 volts AC at 60 kilohertz. Interesting. So, I don't know enough about VFD optimization to know if this is an acceptable waveform, but it's interesting to see what it's doing. So let's also, well, let's throw another probe on here since we have the benefit of all these channels, and let's see. So the other kinds of signals we'll be looking for are the signals actually going to the individual dots. And then we have the signals going to these mesh grids that are in front of each column. And so it's not obvious how those are wired, since I think the wiring is on the opposite side of the VFD. But we'll be able to see some evidence of both of those different types of signals. Voltage off there for now. And let's grab oh, 2 goes out of frame. I can fix that. Okay, so put the grabby probes in all these. Hey, Duke. I wonder if he likes the warm air coming out of all the equipment there. The scope seems to exhaust warm air in the front, but then there's a bunch of stuff underneath that seems to exhaust the other direction, so you could be getting that too. Alright, let's start with green. Set this one up the same way. Strip some more of this ground wire, maybe. It's enough of a ground connection even without any of these connected, but that's dodgy. I mean, this is bad wire. I suspect it's, well, I don't even know if this is copper-coated aluminum. It might just be aluminum. But then, I mean, that couldn't be right, because then it would just oxidize immediately. So maybe it's just very thin plated copper. All right. Man, Tuco looks happy back there. All right, so I'm just gonna grab an arbitrary pin, like this first one perhaps. Nothing. Maybe I'll put the wave pattern back on just so we have something changing. And I guess we can go for the less brightness. That's like half brightness. Sure. I mean, this pattern should be hitting all the pixels. So, ooh, there's our high voltage. Okay, so it looks like the filament is not writing on top of the high voltage, but the other way around. Or rather, there's just high voltage and then the filament is low enough that it doesn't matter. Let's, yeah, it'd be nice if I could just kind of lock all of these together, but I guess I'll keep them separate. It's an interesting waveform that I didn't quite expect. Is that related to the wave I'm displaying, perhaps? No? Is that related to the brightness modulation? Ooh, where did that go? I just set the brightness to max. Now that's always low. Okay, yeah, that's right, because I also changed the content to the screen. Well, changing the brightness definitely changed that waveform. Ooh, now we can see it switching on and off. Well, there's clearly a lot going on here. Let's see if we can at least maybe separate like pixels and columns. I mean, we can also probably do that by counting these, because I suspect these groups matter. Is this one 20? So there's 4, 8, 12, 16, 18, so not 20. This one's 10. This one could be, it could be these are the columns and they have half on top and half on bottom. Let's see what one of these looks like. So those pulses are going up to 40 volts. Hey, Tuco. Okay, I'm just going to run down these and let's look at what all these signals look like with this particular waveform. So that one, I hear you, Tuke. These are also going up to 40 volts. Tuco's rubbing my leg. Oh man, I found this new cat food that Tuco's super into, and now he's probably going to want that all the time. Yeah. Okay. So, and then these guys. Well, this is approximately as deep as I wanted to go into this today. I don't really want to do like an in-depth video on VFDs. I just kind of wanted to get some waveforms while they were easy. But let's at least try all these groups for completion's sake. And I might also actually just put, let's put one from this group on the green channel, and then one from the next group on the pink channel. You know, since we have the channels, let's actually see if we can see the scanning pattern. And maybe trigger on pink. Ooh, that's looking better. I think that's our wave pattern. So I think the so I think the red trace now is one of the column grids, and then the green is one of the pixels. That's great. Let's try another pattern and see if we can make this a little more obvious. I mean, you can see that reflecting the video at this point. It's a little bit of lag from the video processing, but it shuts off immediately on the scope here. Fading in and out. All right, so it's doing PWM by changing the length of each column's chunk of time. So it has, so the kind of capacitive effect that we're seeing there is probably just some artifact of the way the power supply works, or possibly like different loading on that rail. But the important thing is that the length of that pink pulse is changing as the display fades in and out. Can we make the fading more obvious here? I feel like the exposure is super weird right now again. Seems better. Yeah. Do we need more Tuco Cam update? Tuco. Focus the Tuco Cam. Anyway, so we should be able to see, so I think if I move this pink probe, we should be able to see this pattern move horizontally as we look at different, or we're triggering at different parts of the scan. It actually might be more instructive to just move the yellow and the blue probes both to neighbors of the pink one, so we can see all of that next to each other. The filament is not especially interesting, it seems. It's just kind of hanging out there near ground. That's funny. For some reason I expected the filament to be writing at a high voltage, but seems to not be. So I think they might be doing something where there's like a vertical alternation, but I guess we'll see. Oh man, that's really hard to see. That yellow one is just like hiding down there. So I'm gonna intentionally offset these a little bit just so we can see them, but I mean, I'd like to not do that. I think there's a way to, hey Tuco, I hear you. I think that the scope maybe puts the trace on top that you moved last. Let's see if I can test that theory. There's that. This is so funny. Oh, and that's still at 20 volts per diff. That's what we got. So, yeah, so you can definitely see there that these are not every column, but alternating columns. So I think if I put some of the probes on the top side of the VFD, you would see like the columns in between. So let me try moving the blue probe to one of the neighboring pins on the top side of the VFD. I think I'm going to ditch this ground. I don't think I really need it at these frequencies. Hey, Tuco. That is still really hard to see. Okay, maybe I'll just change the scale on the green so it kind of fits in between the others. And let's just probe around over here. So I'm triggering on that purple pulse, but I think if I probe around on the top, we should start to see how those line up in the scanning cycle. So yeah, that's in between. Looks like there's maybe a tiny gap in between columns, but not much. Here's the next one. So yeah, you get the idea. Let's maybe also get a couple of other signals from this group. So these are going to end up being the pixels. So these two groups in the middle together form one signal for each column of this place. We only need 20. There's 10 on each side. These groups of 6 on either side are just the filament. But then I think everything else is going to be a grid of dots representing 2 vertically stacked characters. And so the back will just kind of have wiring for all of those, which seems a little like there'll be a lot of grids back there. Let's see what we've got here. So this is just, let me fix the scale on that to match the green here. So here, the pattern's actually going to be pretty, like you see these contiguous runs probably because of, you know, if you look at the same pixel, like for each of those columns, it tends to come on for a little while, then go off. But if I put some text or something on here, we'd start to see more complicated waveforms. Let's try this program, which has some scrolling text. So that wasn't changing at all as that scrolls. This is probably a pixel from the bottom half of the display, which would make sense since I'm probing on the bottom half. So what if I start probing on the top half? Is that going to give me pixels for the top line? Looks like it. You know, there's a little bit of lag between the two video sources, which is weird. They're both on SDI. Maybe that's coming from the scaler. Whoa, Tuco's sitting on the heating mat. Tuco, you sure you want that much heat? Oh, cat. Well, that's what he wants, I guess. I/O error. Did I just sort something out, or did it just... That's interesting. It seems to have stopped working while I wasn't paying attention. Let's debug that. Let's start out by taking all of these off. Hey, Tuco, what's going on, buddy? Yeah, Tuco probably is a tropical cat. I think he likes warm things. He and I both like to huddle around the warm equipment in this shop when it gets chilly. Although winter is ending, so that really shouldn't need to be a thing for much longer. Okay, what have we got going on here? Huh. Maybe there might have been some short that I didn't notice and it caused this to drop off the USB bus. Because now we've got this back. Anyway, I probably had enough footage from that setup, so I think we can finish the we can end the segment of this where we're focusing on the scope and maybe do some CAD. Hey, cat. Oh, there's a question in chat from Gurkana. What is this little thing with the OLED that plugs into USB? I guess it has a brand name. Let's see. From Drock. There's a bunch of these on... I just went shopping for a bunch of different varieties of like USB power meters, basically. And I think I was searching for like USB power meter, but this, yeah, I don't know why this is called USB protector. I think it might theoretically have some circuitry to protect against overvoltages, but I haven't torn it down to look at what's actually in it, and so far I just use it as a power meter. There's a lot of stuff like this that you can find for like $15 or something, maybe even less. And some of the recent ones even have USB Type-C support, which might be handy soon. They're usually designed to test USB power banks, so they'll start counting charge as well. Yeah, Tuco's hanging out on a very warm part of this mat. Anyway, let's plug this back in. Just run that demo. And let's maybe do some CAD. Such a warm cat. All right, let's I think we can actually actually finish that recording and... Oh yeah, let's stay on this screen, but maybe we can turn off the scope. And actually turn off this. Okay. Alright, so we've got Fusion 360 here, VFD, and a pair of calipers. Let's put away these scope probes. They're all over the place. Let's put these in this drawer where they can be somewhat safe. Alright, so as this file may indicate, I do not consider myself an expert at Fusion 360, but let's try something anyway. I made a few things, like mostly this thing. What does this thing look like? This was from an earlier video. It was based around this circuit board and then some plastic parts for it. I often find myself reaching for Rhino first as a CAD tool because it's really easy to just kind of throw things together with it. I mean, they call it a freeform modeler for a reason. Whereas something like SolidWorks, there's, at least the way I've used SolidWorks, there's much more of a enforcement of, you know, the parts are all structured and it's hard to change that structure, even if you, you know, kind of change your mind halfway through design. Fusion 360 is an interesting compromise because I haven't felt as constrained by the kind of rigorous parametric nature of it, which is nice. I mean, honestly, the main thing I dislike about Fusion 360 is the way it's all cloud-based and kind of, you know, the whole thing is designed to lock you into their ecosystem, so I'm not a fan of that. But, you know, it's something that they put out for free, so it's something that a lot of people find useful. So let's just make a new file. Oh, a new project. Yeah, because I think I will want some more multiple things in here. Now I get to figure out how slow all of the CAD, or all the cloud parts of this are. So, I want to make a new thing. Not by uploading anything. This is like a repository. Maybe I just have to click new and then save it there. Cool, I guess that's the case. So the first thing I want to do is make a rough model of the VFD itself. And I don't even really know what the proper model number of this VFD is, but I'm just going to call it, like, so I think the company that designed this is called IEE, and like one of the brand names they use is Century, so I'm just going to call it IEE Century 20x2. I should probably actually call that VFD something or other instead of just putting the model in there. Can I rename this after the fact? Oh man, most people who see VFD in an industrial context think variable frequency drive, which is also not super helpful in this case. Alright, caliper time. Guess I'll turn this off so I don't, you know, I'm probably not going to get more than just a tingle off of that 40 volts, but it's still nice to not short it out with my calipers. I think maybe I do want my DSLR on the screen. turned that the wrong direction. Yeah. Okay, I think, ooh, this goes back in here. Man, that cat is staying warm, geez. That is some high quality warmness he's acquiring. Alright, so this doesn't need to include all the features. It really just needs to include things that I would need to take into account when designing a mount for this. So the board itself, the location to the connectors, the kind of dimensions of the VFD, the rough outlines of the connectors here that would otherwise be in the way, and basically bounding boxes around parts on the back that I would need to make room for. So pretty rough. You know, I did actually find a data sheet, which I don't know if it pertains to this particular model, but it might be worth looking at it and seeing if it matches, and if so, we have exact, well, or at least like nominal dimensions for this stuff. Let's see, where did I put that? I think it was just like the first result that came up in here. Did I save it? Yeah. So this is the leading candidate for a datasheet. Physical dimensions, page 10. That's not especially detailed. Oh. This might be what we want. Lots of different models. That doesn't quite look like what we have, does it? I think this is not gonna be the same. Oh, 2 by 29 millimeter. I think this is it. The pin layout looks right. Can we do better here? In fact, I might just be able to import this directly into CAD. That would be really nice. So let's start checking some of these. What is the unit? Is that inches? I'm going to assume that's inches and millimeters in parentheses. It's okay, my caliper does inches. I'm going to, well, I was thinking about taking off all of these pins, but maybe I won't. Maybe a ruler first, not calipers. Because I don't know if my calipers actually even open that wide. No, they don't. Well, this could be really handy if this is the right mechanical diagram. Oh, that is dead on, 7.75 inches. And so, and I mean, the pin layout exactly looks like what we've got. 7.45 centers between these holes. Let's see if that matches. Yeah, that's great. I think we have our thing. Let's just check the height real quick. Well, height and thickness. They don't include any of the necessary clearances behind this, so I might just have to do that by hand still, but this is most of what we need. Suggested panel cutout. I think I'll be doing something slightly more organic if I can, but I appreciate the suggestion. What does that say? Man, this is like a scan of a fax from 1940 or something. Oh, jeez. Oh no, it's vector. Maybe this was just mangled by somebody. Oh no, it's a vectorized fax. Okay, maybe actually I can't use this directly because maybe the diagram is not especially accurate, but I could probably use it as a starting point. It's probably, well, I've got the dimensions. Maybe I'll just use those. Oh, they're so hard to read. 2.275 between holes. Yeah, that looks right. Well, at least we know what it's called now. So, and this is the right series. It's just there are multiple kinds of 20 by 2s in this series, and that was the big 20 by 2. Well, can I at least export this sheet and use it as a starting point in CAD? This is page 45. Yeah. PDF. Oh, it is. I actually want to put this on my desktop, thanks. Alright, there's the 20 by 2 single page. Let's see if Autodesk will just let me deal with this directly. Upload button, drag and drop. Sacrificing my files to the cloud. Complete. Are you for serious? Where's my file? I don't understand this program's import, apparently. I'm telling it to import into VFD thing. Does it just not know what to do with PDFs? This is what I did last time. And I clicked that. I have 2 of them now. But I also apparently have 0 of them. Okay. Well, I could do this in Rhino. I know I can do PDFs in Rhino, but I also wasn't necessarily going to be able to rely on these dimensions, so... Oh, this is so hard to read. Let's just see if we can model this. I don't know why that's spinning still. Anyway. Let's do something 2-dimensional here. Let's try to have a way for these to share the screen a little bit. right. I think we're basically assuming that, well, I was wondering whether to make the, I think I want this sketch just to cover the actual circuit board at first, and then I'll model the VFD separately since I'm doing this, since I actually want a three-dimensional piece when I'm done with this. Oh, now I've got to remind myself what the hotkeys are for everything. Of course, dimension is just D. So yay. And if I just keep the project in millimeters, I can try to read the millimeters, which in some cases are easier, in some cases are harder. Use that to double check that I could read the number correctly. Oh, what does that even say? It's like a badly vectorized fax of a crumpled up datasheet printed on newsprint. Is that 2.58? I think we're dealing with 65.5 millimeters. What is that in inches? .58. Okay. So I'm going to use 2.58 inches because that's probably actually more accurate, since I think this was designed in English units, or imperial units, SAE, whatever we're calling them, non-metric. 2.58 inches. Okay. And this also wants holes, so I think we just want to make a construction rectangle that's, or maybe I'll just make some circles. Where is the diameter? .125. That's an 1/8 inch diameter. Okay, got some holes. Let's make some copies of this. I'm going to line these up using constraints, so I'm not really going to worry about moving these around. Did I just overwrite the one that I copied to? Oh, I think I just canceled the move. I still have two. Huh. Okay, now I just want to kind of put these on some construction lines and dimension them. actually want that. Oh, I wanted that to be significantly more planar, actually. Let's stay two-dimensional here. That's what I get for using a 3D input device to solve a 2D problem. I wanted all these to be construction lines. X. Whoa. Did not mean to use the wedge menu. I meant to open the menu, check the hotkey, and then close it. Great. And now... let's make these horizontal. Make these vertical. So 7.45 inches between centers horizontally. And 2.275 vertically. This should get us really close to the designer's intent. And so now we just need to center that in there. I think they're implying that it's centered. Centeredness is strongly implied by the original sketch. So I think I just want to go from center there to center there. Likewise, make both of these construction lines. Make them, well, make at least one of them horizontal like that. And then get this roughly lined up. And then make these the same length. If I can actually highlight both of them. So these need to be equal. Cool, so now these should all be pretty well stuck together. Which is nice. Anything else that needs to go on the circuit board? Potentially the stuff on the back, right? Like, I'll model the VFD itself as a separate object, I think. But I think maybe having this stuff on the sketch could be useful. Yeah, and 2 goes into that heater. Oh, hey buddy, sorry. Misjudged distance. Okay. Well, yeah. Oh, Tuco's making biscuits on the chair over here. Maybe he's in for another nap. Oh, I kicked a bolt and then I think I distracted him. Fickle cat. Anyway. Yeah, whatever. Okay, let's avoid overcomplicating the sketch. Let's just extrude this. Do I care where the origin is? I kind of care where the origin is. A little bit. Not really. I think I'm going to move stuff around eventually anyway. The part of me that insists on doing silly, unnecessary things wants to center this on the origin. I think what I want is to highlight both of those and then have like a midpoint constraint. Yeah. I think that makes it pretty well constrained. So there's our thing. So extrude this. Now that's where we care about the thickness of the circuit board. And this, I just want the board itself, and I do care about not including any of the components in this because I think I want to have something that potentially interfaces with the edge of this board, like by gripping onto it. Oh man, I'm going back into metric. So, call that 1.8 millimeters. There's our solid. It's pretty nice. All right. Well, let's maybe model the VFD because that sounds fun. So, so the VFD, there's actually quite a lot of space between the VFD and the circuit board. Well, you know, I was making a decision about where to start the sketch, but I think I'll just actually make a box. Oh, this still needs a plane to start on. All right, so I guess I need to make a plane first. So I was thinking about making a plane based on this surface and then lifting it up by a measured amount. But I could also draw something from the side, maybe. Maybe that's easiest. Maybe I have to think like a parametric CAD person and draw another sketch on this plane, maybe. So now we're looking at it from the side. I should not use the space mouse when we're doing two-dimensional editing. Where did Tuco hang out? Oh, he's on the heating pad again. Silly cat. Can we get a better view of the kitty? Got my feet in the way. Oh, Tuco avoids the paparazzi. Or maybe he sees me paying attention to him and now he wants to play Bolt. I think the latter. I think he just wants to play Bolt always. Alright, this doesn't really have vertical info except for a max height, because that's kind of the way these guys roll, I guess. So I'm just going to measure that myself. This might be approaching the end of its usefulness. crusty document there. All right. So let's make another construction line. And I think I want to measure the height. So there are two measurements that I can take pretty easily. So if I were to draw a construction line there, I'll make them construction for real in a sec. And then another one that goes from the same point down to the bottom. Those are the two I can get to with my calipers pretty easily. Let's make both of those construction. Oops. Alright, so let's do that. Let's reset this while I'm remembering. Oh, sorry, Tuke. Tuke is really good at evading the paparazzi. He's always one step ahead of and/or behind the camera. Oh, and I can't remember where the switches are on these lights. Alright. Okay, so the thickness of this whole glass assembly, carefully measuring that, it's a smidge over 9 millimeters. I'm going to call it 9 1/4 to be slightly conservative. So that's not the one I wanted. So 9 1/4 millimeters. Then we can make this one just the whole height of the assembly. Well, not the whole height of the assembly, but the height from the base of the circuit board to the top of the glass. So the height excluding all the backside components. So that I'm getting 14.2 millimeters. Just measured at the other side too, just to see how even it is. 13.78 over here. Let's just call it 14. That should be. Well, I think we want to make this err on the side of being bigger, so let's call it 14.2. This is only a model, but we could build it to scale. That would help if we're going to 3D print things. Okay, so that should give us what we wanted from the side. Don't know how much I care about the actual leads for the display. I might just put in something really rough for them. So if I just measure from the end of the leftmost pins to the end of the rightmost pins, it's about 18.5 millimeters. So I might just do something rough to represent the pins with that. Or 18.5 centimeters, sorry. Okay. Now I want those to start pretty much in the middle of this. Can I attach these two midpoints to each other? I don't think. Oh, maybe I can. Oh, I think I can. Cool. Okay, and then I just basically want to draw a rectangle. Yeah, sure. I actually want two rectangles. So let's just put two arbitrary rectangles here. And then I want these that point and that line coincident. Whoa, this needs to be vertical. Then I want this and this to be coincident. Same with these measurements. So this will be the VFD glass. And then this will be our, oh, actually, this was the line we drew for the pins, not the VFD glass. This constraint needs to be modified. We never measured the width of the LCD. It's, oh yeah, we were going to assume the LCD was the same width as the PC board because it's really close, and that'll maybe make things easier if we just do that. It's actually very slightly narrower, but so in that case, I think I can make this point and this line collinear. That didn't work. What did that do? This line and this point? No, that didn't work. I don't know why. Okay, let's try something else. Let's just draw that line. Make it a construction line. Make it vertical. That works. So many different ways of accomplishing the same thing. Alright, so now that's the VFD glass with dimensions. Oh, I don't even know where the cat is now. Hey Tuco, where are you hanging out? Oh. Alright, good cat. CAD. Alright, so this one, I want it to be the pins. So I think I just want this corner and this corner to become the same thing. Same with this corner and this corner. And then this. I'm just going to have this go to the top of the circuit board, since I don't really need to model the portion of the pins that stick through. Okay, so I think that's what we want, for this sketch at least. Now we can do some extrusions. That section, we're going to actually end up wanting to project it to the sides probably, but we can start with an extrusion. So we want both of these pieces, and we want to go both sides, symmetrically actually. And let's see how big the LCD or VFD glass actually is in that dimension. So right there, 44.5. Let's do a couple more measurements. 44.6. 44.4. All right, well, let's use 44.6 as a, or maybe 44.75 as a somewhat conservative number. And that is each way, so this is actually going to have to be half that. Let's see if I can divide by 2 in this field. Maybe not. That'll be 22 and what's that? 375. That's seeming more believable. So let's maybe stick a rough approximation of the legs on this too. And like, I don't want these to actually be thin like the legs. I want them to carve out the space that the legs would need, which ends up meaning that they're probably going to be kind of big blocky things. So I'm just going to measure across all the legs and to see how far out this whole thing needs to stick. So that's 50.5, call it, millimeters. Let's measure the other side too. .27. Cool, so let's call that 50.5. Maybe even 50.75. And again, divide this. So I think that's our, oh, did I only make that go one way? Oops. No, how do I go back to that? Okay. So that's our pin stand-in. And it actually ended up merging with that, so I think I want to merge these also. Combine, that's what they call it here. Alright. So now, this whole thing is our VFD stand-in. It still needs, so it's making room for the display and for the pins. It's got mounting holes clearly visible. It still needs room carved out for the parts on the back. So for the most part, I want to just have kind of a single kind of flat-ish box that covers most of the surface mount parts. But then there are a couple of things that I want to carve out specifically larger cavities for. So the wiring behind the connector and the high voltage transformer in the power supply, the step-up power supply. So, and then we'll also need some room for a USB connector and the USB to serial board, but we'll model those separately in a sec so we can experiment with the placement. I'm gonna see if I can get the camera on Tuco without him leaving again. Maybe I'll also make sure the recording's still going. Oh yeah, good cat. This cat has all the best features. So, put some stuff on the back. So there's a couple of fairly thick components here. So you can see there's the transformer on the left I was talking about, and there's the connector, and I want to leave ample room for that, especially if I'm going to keep using these kind of silly plugs like that. They seem to have very little copper, but they seem to work. Wow, there's like a legit ground test point over here. Oh, and these actually used to be connectors for... I think this had an option for like an external buzzer or something weird like that, or like a button, or... I don't know, there's some weird option there, and I think I trimmed those pins off in order to make this more flat for some other reason. I don't know why I did that. So anyway, I think if we exclude the transformer and the pins over here, there are a couple of other things that all come to about the same level. So there's the pins here, the headers that select a baud rate and select a parallel port mode. And this crystal over here is in a pretty large package. What is that frequency? I hadn't even noticed a crystal in here before. It says MMD079J, so I have no idea what frequency it is. I already turned off the scope, or I would quickly check. So anyway, I think I'm just going to make kind of a box that covers most of this to that height, and then carve out a little extra room for these parts. So... I guess I want that to be basically the whole width of the circuit board, and then the height... Like, really, I want this to be pretty conservative in making room for things, but I want the model to be fairly clear on the edges here, where I could conceivably have plastic grip on there if I decide to do it that way. So, I want to be fairly conservative and get like most of the surface mount parts in here. So I think that means 5 3/4 centimeters. Let's see what that looks like on CAD. What orientation am I even in here? All right. Not that it matters quite yet. Okay. So I've got an angle constraint on that. I want to put the midpoint of this in the origin. And then I want the size of this. Oh, I already forgot the number I just measured. It's 5 3/4. 5.75 centimeters. That looks about right. So that is part of our template here. Let's make that construction. And then let's have this be a rectangle that's lined up to the edges there. And then let's line it up to the center line, have that be coincident. Alright, so this is... Oh, cool. I can also make it still leave room for the holes there. I think I want to carve out a bit of an exception here for the holes. So What is this blue line? Okay, that's the edge of the thing that I'm building. Has no relation to the center of this circle. It's fine. So that's not quite what I wanted, but we can work with that. Let's just make that horizontal. Okay. That's more like what I want, I think. Because the space around the actual screw hole is pretty clear. And so I want the model to generally be conservative, but to reflect that there's room around the screw holes there. Because I do think I would want to support it there. So, let's see if there's a way to duplicate this construction. I might just do this really quick with the keyboard. So I'll make... Okay, that time I got a perpendicular constraint, so I just need to add the tangent. Part of the problem I'm having right now is the difference between the highlighted color and the non-highlighted color is super subtle. I don't know why they do that. I suspect I can change that, but what a weird default. I don't know. I don't know if that makes any difference. Whatever. So that on that side, cool. 2 more of those, and then extrude this. So yeah, I don't think I get a way to... I'm used to Rhino having easy ways to snap to like corners in curves. So like this would usually be a snap point. I don't know if there's a way to do that in this program. So instead I've got to draw a line, make sure the line has the properties I want, and then add a tangent constraint so the line meets the curve smoothly. That's fine. It's just more fussing than I was hoping to have to do. So circle, starting there, tangent to that. Now I have a line that has the right angle constraint, but isn't actually on the end here. Let's make that coincident. And then make that tangent. Okay. Done with that sketch. So extruding that. And now I need a good height estimate. I'm just going to use the depth probe on my caliper. So I think the crystal was probably the thickest thing here. I can verify that. I think 5 millimeters would be plenty of room for the crystal. Ooh, the jumpers need a little more. Six and a half millimeters. That seems safe, 6.5 millimeters. It's looking better. So I mean, this isn't intended to be an accurate model, it's basically like a keep out zone, sort of. It's like when we're designing stuff, this is the envelope that we should leave room for. And then, like when I'm doing this kind of thing, that's often the kind of model that I end up making, because it's a lot less work than making the fully accurate model. Is that like a... There's like a tooltip stuck on the screen. Do I have to save this and then load it again or something? I guess something I did made the tooltip go away. Okay, so the next thing, I need to add that additional space on the two sides here. So let's do that on that same sketch we were just in, actually. So connector land. Let's again give this thing a pretty wide margin. So let's kind of round this up to be 12 millimeters wide by let's call that 12 by 30 millimeters, just to round it up to something round. All right, there's my 12 by 30 millimeters. Whoa, what am I even? That was a new way of selecting things that I wasn't expecting to be using. Okay. So then, I think we just want this vertically centered, and then I will measure the distance between basically the center of that and the edge of the PC board. Oh, that's like exactly 11 millimeters. I wonder if that was intentional. So let's have this be a construction line. Let's have this go from the midpoint to there. And then let's make this construction. Let's make it horizontal. And let's make it 11 millimeters long. Okay, so that's the connector space that we want to leave. Is 30 really enough? Oh, it smells like my neighbors are making bacon. That's so weird. Yeah, I mean 30 is plenty. All right, I won't fuss over that too much. So this transformer, let's give that some room too. I think I want to include this big inductor that's next to it as well. Just, you know, I don't want to. Well, actually, yeah, I think it just makes sense to kind of make a box that covers both of the inductors, just to keep it simple. So the width there, that'd be like 26 millimeters, pretty conservatively, by well, we could just make that square. 26 by 26 is about right, and is a pretty nice wide fit for that. That's easy to line up. So I think that's all the sketch we wanted there. This is like, I was hungry until I smelled the bacon. Let's see. It might be easiest just to extrude these from the sketch and then join them. So the sketch plane in this case was the top of the circuit board, so this should also make it easy to measure just using the depthing tool like I was using before. So to give the transformer plenty of room, let's make that 10 millimeters. 10 seems fine. Okay, and then on the other side, this one actually is going to be somewhat thicker, and I think I want to leave room for some amount of cabling, so I'm going to assume that I'll probably be using something similar to this and include the expected kind of wire bulk in there. So this will leave a cavity that I can then kind of join something to from any point, but it'll already have room for the wires. So oh, sorry. 20 millimeters seems to give enough room for the wire, just barely. Like it'll be tight, but not so tight that it would be putting stress on the wire, I think. Which is, I think, what I want. So 20. Cool. So that's what we would have when we join this together, which I think we should do. Combine those and hide that. We don't need the sketches anymore. Okay. Now we have our VFD mock-up. So this is the top. There's room for the electronics, room for the connector. So because of this, I mean, we've got plenty of room here for like a USB connector and a serial board. But I think before I put the little electronics in here, I might want to, well, let's save this first of all, because I think I want to keep this file and then import this into another file as a component. And then maybe we'll model the pole that we want to attach this to. All right. Data. Make a new thing. I don't know why this is being so spinny. I think I want to close that and then... Oh, the cloud. It's such a good thing this is a cloud program, isn't it? Not even knowing what files are available. Can I do that from here? I thought I wanted to do this in a different file, but maybe... I know I've done it this way before. I think Fusion is just being weird. Let me try to restart this and see if that helps. So I think that side panel that was hung is what I needed to use to actually import that into the other file. I got a hint from chat. Ryan says to right-click on the data panel and go to import. See what I got there. Oh, what? My PDF showed up finally. What's up with that? Thanks, Cloud. Except it's just a PDF. What are you even doing? Why are you opening this in a web browser? Why? It's just a PDF. I didn't need you to cloud host my PDF. I needed you to import it into CAD. Oh, let's see what this does. Yeah. Yeah, so if I right-click the PDF, there's not much I can do with it. If I right-click this part, I can insert it into my current design. I can't save, or I can't do that before until it's, oh, I have to save this one. It doesn't have a name yet, and I can't insert things into it until it has a name. So, I think this is actually going to be the mount. And can I insert it now? Can I insert it now? Oh, yes. Great. Now let's be done with this for a little bit. Component. Cool. So, I kind of do want to angle this. Oh yeah, this might be a good time to actually think about where this is going with all of this light in place. Because I was thinking, one of the decisions I've yet to make about this is whether it needs to have a pivot, or whether I can just make it with a certain angle preset, which might be just like a slight downward angle. So let's plug this in and see how it looks with all the usual lights here. So a little bit of sunlight, all the studio lights. Okay, so that is plugged in, drawing some current. Okay, I think this, I don't know what brightness level it's at right now. It looks really easy to see though. This might be full brightness. So I'm going to point the camera at where I want to mount this, and then I'm going to hold it up there. So you can get a sense for the relative brightness levels here. So those are the computer screens, and then there's just like a super bright light here. I think I need to adjust the camera so the computer screens look natural. That seems about right. So if I try to avoid shorting out the serial adapter on the VFD. So that's kind of nice. Trying not to short this out on anything. So that's about parallel to the pole, and that would not look out of place. It would also look fine angled slightly, but it wouldn't be that noticeable. If I angled it more like that, I think that would be way too much and it would just look weird. So a flat design could actually work just fine for this. So now let's try changing the brightness. So this is gonna get tiring real quick. And I think I do want this case to have some amount of a sunshade because, you know, check that out. It's much easier to see than with the light hitting it directly. But I think that was full brightness, which I wouldn't want to use all the time. Let's try half brightness. Seems to be very similar, actually. Oh, can I rig together some kind of sunshade so I can test this a little more equitably? I don't know if I need to, though, because I think this is looking promising, because even during the day, even without any shade, I can see it. It's not amazing. I might have to turn the brightness up more than I want to, but I don't think there are any showstoppers. So I think I might just press on. Oh, I might have to take a break to get some food soon anyway, but then maybe I'll do a third stream today after I eat. Can I do 3 streams in one day? I mean, the first one barely counted since it was 30 minutes of technical difficulties and cat wrangling. Okay, well, let's go back to CAD and carefully put this VFD down. Glass on glass is probably not the best way to store it. Let's put it on top of something. I think that was the neighbors. Right. Okay. Well, at least the cat's just kind of hanging out. Guess I can turn off that camera view now since it's just getting in the way. Alright, so, oh, this angle got totally messed. I think I decided I wanted this to be like 90 degrees. That might make things simpler for it to just be flat. And if we can have the pole occupy this space, so this is part of why I didn't want the whole thing to be just like worst case, because I think I can have the pole mount take up some of this space and then have electronics kind of on the sides. So what is the diameter I'm working with? I just measured my pole at 35.3 millimeters. It's also maybe closer to 1.4 inches. I think 1.4 inches seems like a round number that these might have been designed to be. If I set my calipers to 1.4, it makes a pretty nice fit. So let's do that. I need a new sketch, like always. This video is up, or the VFD is upside down. Let's make sure we don't have the VFD be upside down. I'd like to get back to the rotation that I made on this when I imported it. Maybe that's move? Maybe rotation is a type of move? Okay, well I just undid a bunch of stuff. I guess I'll just try this again. So The data connector is actually going to be on the left side of the display. Let's just like double check that that's actually the case. If I plug this in, we should see the cursor blink. Don't want this to be upside down. Yeah, so the data cable comes out the left when you're viewing it from the front. So it needs to go around this way. And that way. Nah, I'm happy with that. Okay, back to that pole. So, new sketch, one here. Oh, what did I say, 1.4 inches? Yeah, 1.4 inches. Oh, I need a center line first. Oh, that part is not centered either. It's fine. It's annoying, but it doesn't really matter. Cool, that might be nice. So we could have the pole actually kind of hug pretty close to the display, and then wouldn't necessarily need that much plastic around this. So one of the constraints here is going to be the thickness of the magnets I use, so let's see what kind of magnets are likely going to be in here. Lots of these things. I also have hard drive magnets, but that's probably a little too intense for this. I mean, I think I just want to use an array of little magnets. That's how I've been sticking everything else up to these poles. So, what are these like? 5mm diameter, a little under 1.5 thick. So it's like 1.48 millimeters. So maybe a distance of 2 millimeters between the pole and the VFD is the way to go. Oh, I keep forgetting to see the new Star Wars movie. I don't know how much I care though, because it's like such a different thing. It's like, oh, I could just go see any sci-fi story. I've got my audiobooks here. But, you know, seems like it might be awesome. So the other constraint here is I want the route to extract the pole from this whole thing to be clear. So that pretty much dictates what size. Like at most, I can be you know, kind of carving out a channel that looks like about that. And I mean, really, you know, since I need to kind of keep the space over here clear, the constraint that leaves me with is, well, I want to put a magnet on either side, because that's the kind of farthest over this way I can put a magnet. So I want there to be room for a magnet here, but then this doesn't need to come out any further than like half the magnet's diameter, basically. I think the way I'm going to do this is to just 3D print kind of a cylinder that has a bunch of hollow spaces for magnets, and then just glue a bunch of magnets in. That seems straightforward, and that's worked pretty well for a lot of the other stuff I've made around here that sticks onto stuff. Okay, so in that case, let's just make a little rectangle here that's kind of a stand-in for our magnet. Let's make this 5 millimeters. No, this one. And we said this was half a millimeter? Or like, no, sorry, 1.5. 1.47. 1.48, let's call it. All right. Let's remove these constraints and instead make these parallel. So now this will kind of, whoa. Okay, these dimensions, I want these to be lengths, not perpendicular dimensions. Okay, well maybe I'll change tactics. Maybe this is my reference rectangle, and I'll just make my other rectangles similar to this one. So we'll make these horizontal and vertical again. Do I have to make these horizontal and vertical independently? I can't horizontal vertical a bunch at the same time. That's annoying. Okay. Make another rectangle. Take apart this rectangle. Okay. Oh, I need to make these right angles. Alright, so now I have a little thing I can rotate. Can I copy this and keep the constraints? Not really. Sigh, that's annoying. Well, I think the way I actually want to do this is to make a magnet template that kind of fits on the side, and then to just kind of have an array based on that. So maybe I won't worry about having something that I can move around, and instead just make something in that position. So just type in that size again. And then I want this to be tangent with that. construction lines to the rescue. Oh man, okay, I think now that I'm no longer thinking about bacon, I'm actually starting to get hungry again. I have to go acquire a sandwich momentarily. It'd be nice to know how to... Well, I guess I was thinking about the arraying operation to actually make a bunch of magnet cutouts, but so there's two separate things here. There's making sure there's enough room for the magnets as I designed the surrounding shape, and then there's actually punching out the magnet shapes. And so I think the latter, excuse me, I think making holes for the magnets I can do separately, but here I just want to make sure I leave enough room. So I think that's what this is accomplishing. So let's make this something around like 4 millimeters. And this will be kind of the depth of this hole that I'm making for the post to fit into. So then I want some amount of depth here. I mean, basically I just want a smooth transition at this point. I mean, let's assume this is maybe going to come back. Yeah, this is something that I totally don't know how to do in Fusion 360 yet, because this is one of those points where if I was doing this in Rhino, I would just start like making some curves and making something in space that would eventually work out. And at this point, I'm not quite sure how to get the kind of overall enclosure shape I'm going for, but I think that might be a problem to solve on a less empty stomach. So I'm going to wrap up the CAD portion of this stream, but have a little bit of hanging out with Tuco with the laptop. Oh, jeez. Just noticed somebody's comment that Tuco is probably vegan. Tuco is definitely not vegan. Tuco eats meat pretty much exclusively, as a cat should. I don't know why this just rebooted, but I thought I was going to catch up on chat, and that just got more complicated. All right, come back, computer. Oh yeah, this totally just rebooted. Why did it reboot? I did that when I unplugged it from from AC. Oh yeah. There's another suggestion in chat to look at screens, because, you know, it is a good point that Wildmania brings up in chat that the sunlight in here is probably going to be activating the phosphors in much the same way that they would when they're glowing, so that's not going to be doing me any favors. Oh, there's actually one. I had a little bit of plastic that we could experiment with here. That's a good idea. Let's turn this back on. Off. Why is it off? Some of these little USB current meters also have power on-off switches that aren't always helpful. I'm just going to SSH in and run another example. All right. So this is back with the camera on auto exposure. So yeah, not gonna get the best picture with the auto exposure. It looks a little better in reality than it does on the screen right now, but that might just be my eyes having better dynamic range than the camera. I think this is going to be too dark. This stuff is designed to be transparent to IR, but really opaque and visible, and so it might be too opaque. Yeah, that is too opaque. I also have some polarizers that are not very big, but we could just see if that works. I thought I was going to get some polarizer film, but maybe I didn't. But I've got these little circular, like lens mount polarizers. That definitely helps. It's the well, maybe I will find some film or plastic or something that we can incorporate into this design, because I do think that would help. Oops. Yeah, I mean, I don't like obscuring the VFD, but maybe the way to do this is to have some film in front that makes the display easier to read, but then to use either kind of an open frame design or some translucent plastic to make the enclosure so that, you know, the VFD itself isn't as hidden. That kind of helps. I don't think I had anything else that was super useful for that. Yeah, Tuco's favorite thing lately is fish. He eats, he likes salmon a lot, so his usual wet cat food is like chunks of salmon. Oh, he just tried this recent one that he's super into, like even more than the salmon. It's some other kind of fish, I forget what. It looks disgusting, but he likes it a lot. So, well, Tuco's nap continues, and I think I'm gonna go head off to get a sandwich or make some soup or one of those human things. And if I've got the energy, I might do some more CAD streaming later, since I'm definitely into finishing up this little project in a timely manner, since it's something that I'd like to just kind of do and complete, and it would be nice to actually use this thing too. So, thanks for tuning in. Thanks to all my patrons. Thanks to everyone who sends me hugs and hardware, and thanks to all the fans of Tuco. Happy hacking, everyone, and I'll see you next time.